College Algebra, Chapter 11, Section 3, Geometric Sequences and Series. Now, we've talked about arithmetic sequences. A geometric sequence or progression is a sequence in which each term after the first is obtained by multiplying the preceding term by a constant non-zero real number called the common ratio. So arithmetic is addition, geometric is multiplication. The series of wages 1, 2, 4, 8, 16 is an example of a geometric sequence where the first term is 1 and the common ratio is 2. So each number is obtained by multiplying the previous by 2. In a geometric sequence, the common ratio can be found by choosing any term except the first and dividing by the preceding term. You obviously can't do that with the first because there's no term before it. The geometric sequence 2, 8, 32, and 128 has a common ratio of 4 because 8 over 2 is 4, 32 over 8 is 4, 128 over 32 is 4. The nth term of a geometric sequence. So if we have a term we want to find, if we know the first term is a sub 1 and we have the common ratio and we know which term we're looking for, then the nth term is a sub 1 times r to the n minus 1 power. So try this example. The formula can be used to answer the first question posed at the beginning of the section, which I think is in the book. We didn't actually do on this video. But how much will be earned on day 20 if daily wages in cents follow the sequence? So the first day you get paid a penny, the second 2 pennies, the third 4 pennies, and so on. How much will you get on day 20? Pause the recording, use the formula, resume the recording to check your answer. So a sub 1 is 1, r is 2. So we're going to put it in the formula. A sub 20 is what we're trying to find. So we have a sub 1 times r to the 19th, which means 1 times 2 to the 19th, which is 524,288 cents, or $5,242.88. Here's another example. Find the fifth and the nth term for the sequence. Pause the recording, give it a try, and resume to check your answer. So we have a sub 1 is 4, and our common ratio is -3. For n, we have 4 times -3 to the 5 minus 1, or 4 times -3 to the 4th, which is 324. Using n in place of a specific term, we have a sub 1 times r to the n minus 1. That's going to be 4 times -3 to the n minus 1 power. Now you're going to find r and a sub 1 when you know the third term and the sixth term. Use your formulas, pause the recording, give it a try, and resume to check your answer. So for n equals 3, we know that 20, which is our third term, we get by doing a sub 1 times r squared. And we get our sixth term, which is 160, by a sub 1 times r to the 5th. Now, a sub 1 times r squared equals 20, so a sub 1 equals 20 over r squared. And now we can actually substitute that. What we did is we took that first equation and we solved it for a sub 1. And now we can use that ratio in our second equation in place of a sub 1, and we can solve for r. So that's what we did there. We substituted. And canceling the r squared with the r to the 5th, we have 20 r to the 3rd equals 160. So r to the 3rd is 8, which means r is 2. Now we need to figure out what a sub 1 is. Well, since a sub 1 r squared is 20, and we know now that r is 2, we can solve for a sub 1. So just put in the numbers we know, and we get that a sub 1 must be 5. At a distance of 3 feet, professional golfers make about 95% of their putts. For each additional foot of distance, this percentage is 0.9 times the previous percentage. Write a formula that gives the percentage of putts pros make at distance n, where n equals 1 is a 3-foot putt, and then estimate the percentage of putts made at 20 feet, which means a would be 18, or n, excuse me, would be 18. Pause the recording, give this a try, and resume to check your answer. So the percentage of putts can be written as a geometric sequence. A sub 1 is going to be the percentage of putts made at 3 feet, and A sub 2 will be 4 feet, and so on. So we have A sub 1 times and r to the n minus 1. We know that A sub 1 is 95%. Notice we're leaving it as a percent. Don't change it to a decimal. And then we know our common ratio is 0.9 because they told us that. So our general formula is 95 times 0.9 to the n minus 1. When we substitute 18 in for n, we get 95 times 0.9 to the 17th, which is 15.8. So at a distance of 20 feet, about 15.8% of putts are made. Now, what do we do if we want to add together the terms of a geometric sequence? Well, if you know the first term, A1, and the common ratio, then the sum of the first n terms is given by A sub 1 times 1 minus r to the n over 1 minus r, as long as r is not equal to 1. A geometric series is the sum of the geometric terms. So what we just did there was we found the formula for a geometric series. In the fruit fly population model, with A sub 1 equals 100 and r equals 1.5, the total population after 4 generations is a geometric series. So we would add those 4 together, and there you have it, and we get about 813. So the total population would be about 813. Now find the sum of this geometric series. Pause the recording, give it a try, and resume to check your answer. Okay, using our formula, we know we're trying to find the sum of the first 6 terms because the number at the top tells us that. We know that A sub 1 is 2 times 3 to the first, and that gives us 6. We know that our common ratio is r, just from the layout there. That's what we're multiplying by. So putting it into the formula, we get 2,184. We can extend our discussion of sums of sequences to include infinite geometric sequences. So let's say we've got this infinite geometric sequence. So it's 2, 1, 1/2, 1/4. Our common ratio there is going to be 1/2. That's what we're multiplying by. The sequence of sums, if you were to add these together, 2 plus 1, 2, and then 2 plus 1 is 3. 2 plus 1 plus 1/2 is 3.5. Doing this, and you could do this like on a calculator, how you would do that is to set y1 equal to this formula you see here. And just trust me, this is the formula you want to use. It's the formula for the sum of a geometric sequence. And look at the table. And here's that table. And notice as x gets larger and larger, it seems to be approaching a certain number. In fact, that number it's approaching is 4. So if you keep adding, it's going to approach the number 4. In other words, it converges. The sum of the terms of an infinite geometric sequence with first term A1 and common ratio r, where the absolute value of r is less than 1. And again, notice that the common ratio is a fraction. It's less than 1. Otherwise, you're not going to be able to find the sum of an infinite sequence. But when you have a common ratio of less than 1, you can find the sum of an infinite sequence by doing A sub 1 over 1 minus r. Find the sum of this infinite sequence. Notice that you're going from 1 to infinity, and your r is 3/5. Your A sub 1 is going to be 3/5. Pause the recording, give it a try, and resume to check your answer. Okay, so putting the numbers in, we get 3/2. An application of geometric sequence is calculating the future value of an annuity. Now, an annuity is a sequence of equal payments that you make at equal intervals, like house payments or car payments. The formula for it looks like this. We have S equals R times 1 plus I to the n minus 1 over I. S is the future value, R is the payment at the end of each period, I is the interest rate in decimal form per period, and n is the number of periods. So using that formula, let's see if we can find the future value of this annuity. To save money for a trip, Callie Daniels deposited $1,000 at the end of each year for 4 years in an account paying 3% interest compounded annually. Find the future value. Pause the recording, give this a try, and resume to check your answer. Okay, just put all the numbers in the formula. R is 1,000. I is 4. Well, N is 4 because it's going to be for 4 years. I is 0.03 because it's 3% interest. Putting it in your calculator, and in 4 years, she's got $4,183.63. The rest of this is extra practice, so pause the recording as you go through these and resume to check your answer. Continue this way through the end of the recording.